Hello students, welcome to this video. In this video, we are going to solve the final exam study sheet. And by solving it, we are going to review all the topics needed for the final exam. Let's go and start with the first question. Are these two shapes similar? Are these two shapes similar? So we need to determine whether these two rectangles here are similar to each other or not. How to do so? We know that similar means two things. First of all, the angles are congruent. Okay, that's number one. All the angles must be congruent. So if this is a right angle, then we must have a right angle here. These corresponding angles are congruent. And also all the angles, all other angles are congruent to each other. They must be equal, the same. Okay, that's the first condition, which obviously here it is the same. So the first condition is applied here, no problem. The second condition is that for corresponding sides, which means like this one here, what is the corresponding segment for this side here? It is this segment with 2 centimeter length. Okay, what about this one here? It is also corresponding to this one. Okay, what is the second condition? The second condition is for corresponding sides, there must be constant ratio between them. So if we just divide these two sides by each other and calculate the ratio between them, okay, this ratio must be equal to the other sides, but we just remove the bottom sides because they measure the same. So we will have, of course, the same ratio. But what we need to check is this ratio, is it equal to the ratio between these two sides, 6 and 12? Okay, let's go ahead and find out that. How can we calculate that? Let's start now solving the question. We are going to solve it as we have just read it in the exam, and we need to solve it now. We look at the two rectangles and assign two corresponding sides. So we first said that this side here is corresponding to this side. So we need to divide them in order to find the ratio. I suggest you always divide the second shape by the first shape, which means that you need to calculate the ratio between 2 divided by 4. Okay, and you can simplify that fraction by just dividing both sides, numerator and the denominator, dividing them both over 2. So you will get 1 over 2, which is a half. This is the ratio between the first two corresponding sides. Okay, we need to check the other two corresponding sides to see whether we will have the same ratio or not. The other two corresponding sides here are this side here with the length of 6 centimeters and this side here with the length of 12 centimeters. Okay, let's find out the ratio between them. Is it going to be the same ratio or not? So we divide the second one over the first one, 6 over 12, and pay attention that here we have 6 in the numerator. We cannot write it 12 over 6 because we just chose at the first time here that we will need to divide the first shape over the second shape over this first one. So we need to follow the same process each time. Okay, how to simplify this fraction? There is a common factor between 6 and 12, which is 6, so we can divide both sides on 6 directly. Okay, and we can calculate that 6 divided by 6 equals 1, and 12 divided by 6, it's 2. So, yeah, here we have the ratio between them. Is it the same ratio of the previous one? Yes, it is a constant ratio. So, okay, if we just need to look to the other sides, like these two sides, because these measures the same, so we will have the same ratio. Now, what can we say about these two shapes once we have a constant ratio? What do we say about these two shapes? We say that these two shapes are similar to each other. So the answer will be yes, these two shapes are similar. Why? Because the ratio between the corresponding sides is a constant ratio. Okay? Okay, let's try again with the next example, with the next question here. Are these two shapes similar or not? How can we determine that? We just need to calculate the ratio again. We look at the angles, and obviously the angles are congruent. So there's no problem with the angles. Let's now try to find out the ratios. So where do we have corresponding sides here? We can see that this side here is corresponding to this side, right? What other corresponding sides we have? 6 here is corresponding to the 16. Okay, so let's start by the first pair of corresponding sides. We need to divide the second one over the first one. So what we need to write is 2. So we're taking these two first, okay? These two corresponding sides. 2 divided on how much? Exactly, over 8. Yes. This is equal. We can simplify this fraction. Dividing both parts by 2, we will get 2 divided by 2, 1. 8 divided by 2, it's 4. So the ratio between them is 1 over 4. We need to check whether the ratio between the other two corresponding sides, which are 6 and 16, is the same ratio or not. Let's calculate it. The same process. We divide the second shape, which is 6 centimeters here, by the first shape, which is 16. And then simplify this fraction. 16 we cannot divide 16 by 6, but a common factor between them is 2, so we can divide both sides by 2. Okay, what do we have here? 3 divided by 8. And there's no more common factors between 3 and 8, so this fraction here is in the simplest form. It is now in the simplest form. Okay, so the ratio between the other two corresponding sides is 3 over 8, which is not the same ratio as the first two corresponding sides. So because these two ratios are not equal to each other, what can we say about these two shapes? They are not similar. Okay, because the ratios between them is not a constant ratio, so we cannot say that these two shapes are similar. So the answer for this equation is going to be no, they are not similar. Okay, I hope now you are excellent at determining whether these two shapes are similar or not. It's just a simple process of dividing and finding the ratio of corresponding sides. Okay, so let's go now and solve question 3. Question 3 is asking to determine whether these two triangles are congruent or not. Okay, first of all, let's remember what is the meaning of congruent. To have two congruent shapes, we must have the same measure of all corresponding angles. So all corresponding angles must be measuring the same, and also all the corresponding sides must measure the same. Okay, so there are two conditions. First of all the angles or the corresponding angles must be the same, and then all the corresponding sides must measure the same. Let's look at the two triangle and check out the first condition. The first condition is about angles, so we need to figure out whether these two angles are corresponding to each other or not. Okay, let's look at this angle here. It is a right angle, and we have also here another right angle. Okay, so these two angles are corresponding to each other and they are equal in the measure, so they are equal to each other. That's great. Okay, let's look at another angle, a single arc angle here. What is the meaning of single arc? The single arc sign is used to say that these two angles with a single arc are equal in the measure. Okay, so the meaning of a single arc is that these two angles measures the same. Okay, what is the meaning of double arcs when we have double arcs here and another double arcs here. Because they have both angles here have double arcs, this means that these two angles are equal in the measure to each other. Okay, so they are equal to each other, these two angles, because of the arcs. Okay, so we can notice here that all the angles measure the same, or the corresponding angles have the same measurements. So we can say that for the first condition, which is the angles, so it's just right, it's all right. Okay, so all the angles measures the same. Now let's check the sides, the corresponding sides. Okay, because the second one is rotated, we can just determine the sides by the following. Look at the right angle. The side that is exactly in front of the right angle, here in front of the right angle, the hypotenuse of the triangle, we can notice here that it is 50 feet, and it is the same here, it's 50 feet as well. So these two sides measure the same, and they are corresponding sides and equal in the measure to each other. Okay, so they are equal. Okay, let's check another two corresponding sides. Look at this side. This side is connecting the right angle with the single arc angle, this one here, and it measures 40 50 feet, right? Okay, which one is that? It is the one connecting the right angle with single arc, and it is also 40 feet. Okay, so these two they are corresponding sides and they measure the same. Okay, what about the third segment we have here? We have this side here. It connects the right angle with the double arcs angle, and here the one which connects the right angle with the double arcs angle, this one here measures 30 50 feet, and the other one measures also 30 feet. Okay, so these two sides are corresponding and congruent. So do all the sides congruent to each other? Yes, they are congruent to each other. So what can we say about these two triangles? They are congruent. These two triangles are congruent. So the answer for this question is going to be yes, they are congruent. Okay, let's look at question 4. If these two shapes are congruent, so it is mentioned in the question that these two shapes are congruent, which means that the angles, or all the angles are equal, the angles, okay, and also all the sides are congruent to each other, and sides are just congruent to each other. Okay, and the question need us to find the value for x. Hmm. Let's see. X is the side connecting the right angle with the single arc angle. This one here. Which side is that? It is the one here. Single arc angle and the right angle. So these two are corresponding sides, and because the two triangles are congruent, these two sides also must be congruent. So what is the value of x in this case? It must be equal to 400 feet. Okay? Yeah, that's it. We can just, this is the answer for the question. Now, we can just look at other sides, corresponding sides, but like, look at the side that is connecting the right angle with the double arc angle, this one here. Where is that here? Double arc angle with the right angle. Are they measured the same? Yes, they both measure 300 feet. Okay, look at the side that is connecting the single arc angle with the double arc angle. It measures 500. Is it the same here? Double arc with a single arc. Yes, it is also 500 feet. So these two triangles are congruent. And the answer for this question is that x is equal to 400. Okay, we can go now and solve question 5. Now, if these two shapes are similar, what is the value of x? Now, keep in your mind that the meaning of similar means two things. First of all, angles are congruent. Okay, so when we say similar, it means that first of all, angles are congruent. Okay, so they measure the same. And also, another thing we can just understand from the word similar is that the ratio, and remember the ratio for similarity, we're talking about the ratio between the corresponding sides must be what? Must be the same, is constant, is a constant. Okay, it must be the same ratio between the corresponding sides to say that these two sides are similar, to say that this shape just have a dilation than we have the other one. So that's why we call them similar to each other. Okay, for the first condition, the angles, we can check that directly and see that all the corresponding angles are actually equal to each other like we did in the previous example. Okay, so we can check the angles and all the angles are congruent. So that's okay, no problem with the first condition. The second condition, it says in the question that these are similar. So this means that the ratio between the corresponding sides must be the same ratio. Let's let's write down in that in an equation. Okay, look at the side that is connecting the double arc angle with the right angle, this side here. Okay, which one is that here? The double arc angle with the right angle. It is here. So these two sides are corresponding. What are the measures of these? 12 and 6. Okay, let's write down the ratio between these two corresponding sides. We can write that like the following. The second one over the first one. 12 divided by 6. Okay, this is the ratio between the two corresponding sides. Let's look at another two corresponding sides. Let's look at the side that is connecting the right angle with the single arc angle. Okay, it is this one here, a right angle and a single arc angle. Okay, how to write down the ratio between these two sides? The ratio here is the second one over the first one. So it is 16 divided by 8. Okay, let's look at another two corresponding sides. Let's look at the side that is connecting the double arc angle with a single arc angle. This side here. Okay, it is equivalent to this side here, or let's say it's corresponding to this side here. Okay, so the ratio between them is going to be the second one over the first one. So it is x divided by 10. Okay, so these are the ratios between the corresponding sides. Now, because these two triangles are similar, what we are going to say about these ratios here? They must measure the same. The ratio must be constant, which means that these are going to be equal to each other. Okay, so all the angles are, all the ratios are equal to each other. So this is what can be claimed from saying that these two shapes are similar. Okay, how can we use this in order to solve the question? Let's start from the beginning and I'll give you just the direct way to solve this equation. Okay, so we understand now that because these two shapes are similar, the ratio between corresponding sides are equal to each other. Now, we wrote that like the following, but actually what we need to find out is x, so we only need two pairs of corresponding sides in order to find out x. So we can just erase the first one. Okay, so here we have an equation between x and another ratio, or we can just erase the first one, or the second one here, okay, and just write down the equation between x and another and another two corresponding sides. Let's do it from the beginning. Here we have two triangles, okay, and we need to check out on or find out the value of x. X is corresponding to the segment that is connecting the single arc with the double arc, which is this one here. So we write down the ratio between these two corresponding sides like the following. X divided on the first one, which is 10 centimeters. Okay, this must be equal to the ratio between any other two other corresponding sides. You can take these two corresponding sides, okay, and you can take these two corresponding sides, just one pair of them, okay, one pair of corresponding sides. I'll take 16 and 8. Okay, how can we write down the ratio between 16 and 8? The second one, which is 16, divided in the first one, which is 8. Now we need to solve this equation. We have an equation here and we need to solve it exactly like how we just learned in the first semester. Okay, so to solve this equation, we need x alone. We need x alone without anything divided or multiplied, added or subtracted from that side. Okay, so what do we need to remove from this side? We need x alone. We need to remove the 10. We don't need it. Okay, what is the mathematical process between x and 10? It is a division. Can we get rid of the division? We do the inverse process. We multiply by 10. Is that it? Nothing else? We need to multiply both sides. So we multiply both sides by 10. Okay, the first side, 10 divided by 10 is just 1. So these two cancels with each other. Okay, so what are we left with? What do we have only the first side? We have x alone. Okay, that's great. X alone is equal to 10 multiplied by 16, which is 160, divided by 8. And how much is that? You can keep the 0, and 16 divided by 8 is just 2. So the value for x here is that x equals 20. 20 what? We can write it down there. We can write it x equals 20. What is the unit? 20 centimeters. Exactly. Okay. Do we understand now how we used the similarity in order to find out mysterious sides? That's it. This is very important skill to have for the final exam. Okay, that's it for question 5. So the answer is that x equals to 20 centimeters. Okay, let's go with question 6 now. For question 6, you need to understand dilation. And what is the most important thing to notice here? Okay, let's read out the question. In the figure, square A is similar to square B. And similarity means that these two squares maybe just gone through dilation. Okay, which scale factor was used to dilate square A to square B? This is the most important thing to pay attention about in the exam, where we are dilating. So we are dilating these two squares and we are dilating A to B. Okay, so we are moving from A to B. Okay, when we have a smaller shape like A and dilate it to a bigger one, what will be the scale factor? Is it going to be 1, or is it going to be greater than 1, or the scale factor in this case is going to be less than 1? When we have the shape enlarged, then the scale factor must be greater than 1. Always remember this. Okay, but what if we have a scale factor equals to 1? Then we will have the same shape. Like, let me just write them down like these. Okay, so if we have a smaller shape and it became a larger one like this, then the scale factor in this case, the scale factor is going to be greater than 1. Okay, but if we have two shapes the first shape was like this, and the second shape is exactly the same as the first one, exactly the same. It's not larger or just smaller. The scale factor in this case is going to be equal to 1. Okay, if we have two shapes, the first one is large and the second one is smaller, okay, so we reduce the shape or just make it smaller. In this case, the scale factor of the dilation is going to be less than 1. Okay, it's gonna be less than 1. Okay, and always remember the rule for dilation. When we have a dilation with a specific scale factor, okay, and the sides of a shape was something like, let's say, 6 and 5, like this rectangle here, if we are going to dilate this shape with a scale factor equals to 2, okay, how can we find out the measures of the new shape? The new shape. We multiply the scale factor with each side. So this side is not going to be 5, it's 5 times 2, so it is going to be 10. And then the other side here is going to be 6 times 2, which is a 12. Okay, this is the dilation. This is just a revision for the dilation. Now, based on our understanding of dilation, we're going to solve this equation. Okay, as I've said, the most important thing to notice in this equation is where we are dilating. We are dilating from A, from the smaller shape, to the biggest one. So the scale factor in this case is going to be greater than 1. Okay, so let's start. What's make it easier here is that A is a square, so all the sides have the same measure, which is 5. So the 5 meters are going to go through a dilation, so we must multiply that 5 with the scale factor, so 5 times k is going to give us how much the new measure of the side is 15. So 5 times k is equal 15. What do we need to do in order to find out the scale factor in this case? It's like solving an equation, and the variable here is k. So how do we solve this equation? The mathematical process between k and 5 is a multiplication. So we divide by 5, and we cannot divide a single side, so we must divide both sides of the equation in order to find the value for k. So the first side, 5 divided by 5 is just 1. What we are left with in this side is just k, and k is equal to 15 divided by 5, which is 3. The scale factor in this case is equal to 3. Can we check that? Yes, we can. Multiply 5 times 3. How much is that? It is 15. Okay, so that's correct. Now, another question. Is this a scale factor greater than 1 as we have just expected before solving the question? Yes, it is greater than 1. So, our answer is correct. Okay, so for question 6, we say that the scale factor, which is k, is equal to 3. Okay, let's try a similar question, which is a question 7. In question 7, again, the most important thing to notice that we are dilating from B to A now. Okay, I'm just gonna write down in red, from B to A. So we are moving from the bigger square to the smaller one. Okay, so the original shape was big, and the new shape, the image of that shape is now smaller. Now in this case, what is the the scale factor? Is it going to be greater than 1 or less than 1 or equal to 1? Of course, because this shape has been gone through a reduction, or it has been it just became smaller. K, which is the scale factor, must be less than 1. Okay, we just expect that before solving the question. Now let's solve it the same way. What is the measure of the original shape? the original figure, not the image. Okay, the original one. We are moving from B to A. So what is the measure of B? The original shape, the first shape. Okay, if not the image, it's a 20. Okay, so we write down 20. This 20, we must multiply it by k. So 20 times k gives us how much? Gives us the new measure of the shape, which is how much? It is here 5. So 20 times k equals 5. And what do we need to do now? Just to solve this equation. It is a multiplication between 20 and k, so we divide both sides. At the first side, the 20 divided by 20 is just 1, so we only have k now. What about the other side of the equation? We have 5 divided by 20. We can simplify this fraction by dividing both the numerator and the denominator by 5, and we will get 1 over 20 times divided by 5 is just 4. So in this case, the scale factor is 1 over 4, 1/4. K is equal to 1/4. Is it smaller than 1 as we have expected? Yes, it is. So our answer here is correct. Let's just try it. We can just check that by multiplying 20 times 1 over 4. Is it going to give us 5? 20 and give us 5. 20 divided by 1/4 or multiplied by 1/4 is just 20 divided by 4, which is of course equals to 5. So our answer here is correct. K is equal to 1/4. Now let's go to another type of questions, which is asking about giving you a graph and ask about it. Here, the figure shows a reflection of a rectangle from quadrant 1 to 2. Okay, so we moved from 1 to 2. So this one here is the pre-image, and this one here is the image, right? Okay, so there is some kind of a transformation that happens to this side, and it is of course a reflection. But this reflection, is it over the x-axis or over the y-axis? How can we know that? We ask ourselves, where is the mirror in this reflection, right? We can imagine that like there is a mirror. Okay, if we put this mirror on the x-axis, then the image of this triangle here, this rectangle, is going to be where? Down there, behind the mirror, right? Okay, so the mirror is not on the x-axis. Where is the mirror actually? Of course, it is on the y-axis. So it is like just putting an object in front of the mirror and have the image behind the mirror. Okay, so this reflection is over the y-axis, not the x-axis. Okay, let's go with the question 9 now. And all of the following questions are going to have the same figure, okay, but asking about different kinds of transformations. Different kinds of transformation. Okay, let's remember the types of transformation before we just move on. When we are saying that transformation, okay, let's go to this one. Just talk about transformations. What are the types of transformations we have just studied in this unit, in this chapter? We talk first of all a translation. Translation. Okay, and we talk also a reflection. Now we will talk about each one. So we talked translation, then reflection, then we talked about dilation, and we talked about rotation. Now let's just have some kind of an example. Translation. If we have a shape like this square here, and we want to translate that shape, we just move it. Okay, so the figure is going to be exactly the same shape, but in a new location. relocate the object. We can put it like just moving that from that original square to a new position here, 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 without changing anything else. So this is called a translation. Okay, a reflection is exactly like this one we have here. It's like having a mirror, and this shape has been reflected behind the mirror. It just reversed. The right is now left, and the left is now right. Okay, in that case, this is a reflection. Okay, what about dilation? If we are going to dilate an object, it's just like making it bigger or smaller. Making the shape bigger or smaller is called dilation. Okay, what else we have? Other types of transformation. It is rotation. Rotation is just to rotate the object counterclockwise like this or clockwise like this. Okay, so this is the rotation. Now these are types of transformations. We can now answer question 18 actually. What type of transformation appears here? It's of course reflection transformation. And we can have a composition of these transformations. We can say that for this example, we have a reflection, and if we dilated the shape and make it bigger, so in this case we have a dilation and reflection. Okay, it's enough. I'm not going to ask you about um, a composition of transformation in the exam. So I'll keep it as simple as it is. Well, it's very helpful to just review the types of transformation that we have studied. Now, let's go back to the questions above and start by question number 9. We have a rectangle here. It's called ABCD, okay, and it is located as mentioned here. Now, if the figure, the question is asking about, if the figure is translated 4 units left, what are the coordinates of C prime? So which point we are concerned with? C prime. So only look at C prime. C prime. Now, what are the original coordinates of C? As we can see here, put your finger on the point and move directly in a straight line to the x-axis. You reach this point here. So you are going to have 1, 2, 3, 4 squares. So this means that the x coordinates of this point is 4. Okay, what about the y coordinates? Just put your finger again on C and move directly in a straight line to the y-axis. You will reach this point here. Count the numbers of squares between the origin and this point. It's just a single square. So we say that the y coordinate of this point is equal to 1. Okay, so the coordinates of C are 4 and 1. Okay, now what do we need to do for the C? We are going to translate it 4 units left. So imagine that you are at C now and you are moving 4 units to the left. 1 square, and then 2 squares, and then 3 squares, and then 4 squares. You will reach this point here. Okay, let me just write it here. This point here. Okay, what are the coordinates of this point? At the x-axis, it is the origin, so it is 0 in x-axis, and at the y-axis, it is one square above the origin, so it is positive 1. Okay, so the new coordinates of the point after the translation, it's going to be C prime, 0, and 1. 0 and 1. After the translation of the point C, which was, we can write it like this, C, which was 4 and 1. I don't need you to write all of that in the exam. Just write down the final answer, which is C prime is going to have the coordinates of 0 and 1. Okay? Okay, let's try another type of transformation by solving question 10. So question 10 is asking again about a translation 4 units down. For which point? For B. So we are only concerned with B. Look at B. This is B. And imagine you are at B now, and you need to do a translation. How many units? 4 units down. Let's move down 4 units. 1 unit, 1 square, 2, 3, 4. So you will reach at where? At C exactly. Okay, you will reach at C. Okay, what is the coordinates of the new point that you have reached? This point here. This point have the coordinates. As you can put your finger on that point and move directly to the x-axis, you will find out that there are 4 squares to the right of the origin. And how much is the y coordinates? It's just 1. So the new point B prime, the point of the image, is going to have the coordinates of 1, of 4, and 1. That's the answer. Okay, let's try another type of transformation by doing question 11. Okay, this is a translation of 2 units left and then 4 units up. Which point we are concerned with? It's D prime. Okay, let's go. You can start by moving up or left or right. It's okay. So for D, imagine that you are at D now and you're moving 2 units to the left. So you will reach this point here and then 4 units up. 1, 2, 3, 4. So you reach this point here. This point is going to be D prime. Okay, what is the coordinates of this point? D prime, in this case, as we can see from the figure, and we can calculate that, it is 1 unit. You can put your finger there and move directly to the x-axis, and you will find out that this is 1 square to the left of the origin. So it is -1. Okay, what about the y coordinates? There are this point here. How many squares? Count from the origin. 1, 2, 3, 4, 5 coordinates. 5 squares. So the coordinates of D prime are -1 and 5. Okay, this is the answer. Let's try out another type of transformation. Let's go a rotation this time. Rotation 180 degrees clockwise about the origin. What is the coordinates of A prime? Okay, first of all, we are concerned with A, and we need to find out what is the rule for the rotation. How can we rotate a point? So let's remember the rule of rotation 180 degrees clockwise, which is actually is the only rule that we have to memorize from that lesson, from the rotation lesson. Okay, so from the rotation lesson, the only rule we are asked to memorize is the rotation rule. Is this rule, the rotation of 180 degrees clockwise about the origin. Okay, as you can remember, the rotation, if we have a point which has x and y coordinates, and we want to rotate it as it mentioned exactly in the question, so it's 180 degrees clockwise about the origin, we are going to have the coordination of the new point is going to be just -x, or just reverse the sign of x and then reverse the sign of y. Okay, so this is a rotation of what? What do we say about this rotation? It's 180 degrees clockwise about the origin, Okay, this is the type of rotation in this case. 180 degrees about the origin. That's the rule. Okay, just reverse the signs. Let's take another few examples before we solve the questions. If the point were 5 and 1, the new image is going to have the coordinates of -5 and -1. Okay, let's have something negative. If we have -1 and -2, the new point is going to just reverse the sign of the first one. It's 1. And they reverse the sign of the second one, so it is 2. Okay, let's try the last point. If we have -1 and 1, in this case, after a rotation 180 degrees clockwise about the origin, we will just have to reverse the signs. So the first one is going to be just 1, and the second one it's positive, so we make it negative. So it's going to 1 and negative 1. Okay, these just are few examples to practice on this rule here. Now let's back to the question. The question is asking about rotation, and we now have the rule for rotation. Okay, we can just move it like this. Okay, yeah, and we need to apply it to which point? To point A. Now we will ask ourselves the following question. What are the original coordinates of point A? A, what is the original coordinate of A? Look at A, put your finger there and find out the coordinates. It's 1 on the x-axis, and on the y-axis it is 1, 2, 3, 4, 5 on the y-axis. Now after a rotation 180 degrees clockwise about the origin, what are the new coordinates of A prime in this case? Just reverse the sign. Both of them are positive, so we will make them both negative figures, like here. -1 and -5. Okay? So the answer is that the coordinates of A prime are going to be -1 and -5. Okay, let's go ahead and try another type of transformation by solving question 13. Question 13 says that this type of transformation is a reflection and it is over the x-axis. What are the coordinates of C prime? So we are concerned with C prime. Now, do you remember the reflection rule? It is just easy. If we have the coordinates of a point, x and y, and we have two rules of reflection actually. Okay, so I write 2 points, x and y coordinates. The first rule is just for the reflection over the x-axis. If we have a reflection over x-axis, so this one is over x-axis, okay? And the second rule is that if we have the reflection over the y-axis, what is the difference between them? Okay, in the first case, if we have a reflection over the x-axis, we keep the x coordinates as it is. So we don't change the x, we only reverse the sign of y. If it was negative, it will become positive. If it was positive, it will become negative. So this is the rule, just to reverse the sign of the y. If we are moving or just reflecting over the x-axis. What if we are reflecting over the y-axis? We keep the y coordinates as it is and just reverse the sign of the x-axis like this. Okay, we just reverse the sign of the x-axis and keep the y-axis as it is. Okay, which one we are going to use in this case? The reflection here is over the x-axis, so we are going to solve to use the first rule. Okay, we are going to solve with this first rule. So I'm just gonna move this down there. Okay, now let's use the first rule in this case for this question. What are the coordinates of point C that we are concerned with? We have previously calculated those and they are equal to 4 at x and 1 at y. So C has the coordinates of 4 and 1. Write them down, and after the reflection over x-axis, what are the new coordinates of C prime, which is the image of C? We will keep the x coordinates as, what is it? It is 4 here, and we keep it as 4. And we need to reverse the sign of the y coordinates. It's +1 here, so we make it a -1. So what is the answer of this question? It is that C prime has the coordinates of 4 and -1. Okay, that's it for this question here. Let me erase all of this and move on to the next question. And the next type of transformation is just dilation. We have a dilation here. Okay, so for this dilation, what is the scale factor? it is a dilation here, and the scale factor is a half, 0.5. K in this case is equal to 0.5. What is the coordinates of P prime? So we are concerned with the point P. What are the coordinates of P? As you can find out from the shape, it's 4 on X, and on the Y-axis it's 5. So it has the coordinates of 4 and 5. Put your finger there and move directly to the y-axis and count the squares. You will find out that it is 5 squares, so the coordinates are 4 and 5. Okay, before we continue, what is the rule for dilation? If we have a point that has the coordinates of x and y, okay, and we need to dilate this point with a scale factor of k equal to something, okay, then we need to rewrite the new coordinates of the image, but this time we will calculate k times the x coordinates and k times the y coordinates, like this. We will multiply both the x and the y coordinates with x. So the x coordinates is going to be k times x, and the y coordinates are going to be k times y. Let's apply this to the point that we have here. The point here is B, and it has the coordinates, and what we have found here, it is 4 and 5. Okay, and we need to dilate this point using a scale factor of how much? The scale factor here is going to be equal 0.5, as it has been mentioned in the question. So in this case, we will have the new coordinates of the image P prime. It is like the following: 4 times how much? Times 0.5. Okay, times k times 0.5. Okay, and what about the y coordinates? This is for the x coordinates. What about the y coordinates? The y coordinates is going to be 5, which is the original coordinates, times the scale factor, which is a half here, 0.5. Okay, so now what are the coordinates of P prime in this case? 4 times 0.5 is going to be 2, and 5 times 0.5 is going to give us 2.5. Why? Because it is 5 divided by 2. And how much is that? It is 2.5. Okay, so these are the coordinates of the image of B, which is P prime. 2 in x and 2.5 for y coordinates. Okay, now let's try another type of questions, and this type of questions is asking the same transformation, about the same types of transformations, but this time we do not have a graph. This time we do not have a graph. Like this question here, question number 15. We have a rectangle this time, and this rectangle is called LMN, and we have the vertices of that rectangle. It's like giving us a graph, but this time it just gave us the coordinates directly. Okay, the question is asking, well, what are the coordinates of the image of point M? So which point of these three we are concerned with? In this case, we are only concerned with M. After a dilation with a scale factor of 4. Okay, so which rule we need? The rule for dilation. And the rule for dilation is easy. It is exactly like the previous question. If we have a point and it just goes over a dilation, the new coordinates of that point is going to be k times x and k times y. Okay, let's apply it for this exercise, which we have M here. M has the coordinates of how much? -2 and 3. And we need to go over a dilation with a scale factor of how much? In this case, k equals 4. So the new coordinates of this point in prime are going to be equal to how much? K times x coordinates, which means 4 times -2, Okay, that's for the x coordinates, and for the y coordinates, it's going to be 4 times 3. Okay, so what are the new coordinates for the point M prime? Okay, the image of M, which is the image of M, it's going to be -8 and 12. This is the answer. Okay, so it is the same process, but now it just given us the vertices without an image. So that's it, actually. Okay, let's try another question. We'll choose all the questions are actually about transformations, but for this question it is 16, and we are asking about this quadrilateral, okay, and it has the vertices EFG. EFG. Which one? EFG and H, of course, four vertices. We are concerned with the coordinates of point E, so we need only to look at E. After a reflection across the y-axis, a reflection across the y-axis, and we know the rule for the reflection, right? I just wrote it down in a previous question, but we didn't use it. Okay, this is the rule for the reflection over the y-axis. We just keep the y coordinates as it is and change the sign of the x coordinates, and we do the inverse in the if we are reflecting over the x-axis. So let's apply this rule now and calculate. The original coordinates for point E are -2 and 6, and we need to go over reflection over the y-axis. So E prime, which is the image of this point, is going to have the coordinates of, just reverse the sign of x coordinates. The x coordinates here are -2, so let's just reverse the sign of that. It's going to be just a +2. Okay, what about the y? We just keep it as it is. So we will have 2 and 6. Okay, this is the answer. This is the coordinates of the image of point E after a reflection across the y-axis. Okay, we can clear that now and move on to the next question. And it is the last question actually. We have solved 18 earlier. We will talk about it. Now for this equation, we have the quadrilateral EFGH, and we are given the vertices of this shape here, and we are asking to find out the image of point F. So we are only concerned with the vertices of F, okay? After this triangle, actually this is not a triangle, okay? So just remove these guys. After it has a rotate, it has been rotated 180 degrees clockwise about the origin. Now you know the rule for rotating 180 degrees about the origin. What is that? Can you remember it? Rotation 180 degrees clockwise about the origin. What is the rule for that? Exactly. We just reverse the sign for both of the coordinates. So if it's positive, it's going to be negative, and if it's negative, it's going to be positive for both coordinates of the image. Just forget about these letters here. Now, what is the point that we have here? It is F, and it has the coordinates of how much? -2 and 0. It's given in the question. And we are going to have a rotation, a clockwise rotation 180 degrees about the origin. So the new point, F prime, is going to have the coordinates of how much? Forget about these. Okay, we can write it down like this. Okay, it's going to have F prime. In this case, we just reverse the signs. So look at the first one, it is negative, so we put it +2. Okay, 0, just stay like the same, 0. There is no positive or negative 0. Okay, so 0 have no sign. So just keep it as it is. The answer for this question is that F prime is equal, the coordinates of F prime are 2 and 0. Okay, so that's it for the final exam materials. By watching this video, you have just reviewed all types of questions all the materials needed for the final exam. And we can talk again about this the final question. So for this type of question, we said that the transformation has maybe one of the fourth transformation, maybe a translation, maybe a rotation, a reflection, or a dilation. And we see here it's just a reflection, like we have a mirror here. It is a reflection, and more precisely, we can say that this is a reflection over the y-axis. Okay, so the answer for this question is a reflection over the y-axis. All the materials needed or the understanding and the knowledge needed for the final exam has been just explained in this video. There are, if you have anything else that has been hasn't been mentioned here, then it is not needed for the final exam. If you solve all of these questions, you are ready to have a full mark in the final exam materials. Okay guys, thank you very much. See you later.